Welcome back, ladies and gentlemen, to the basics of geometry, and this time we've got part 2, in which we're going to talk about angles and a few other little things. This is not as big as part 1, so fair warning or fair rejoicing, however that strikes you. I just wanted to remind you, we talked about what a ray was, and this pink was a representation of a ray. It starts at V and goes in this direction forever, and so is this. So I want to go ahead and I'm going to draw that ray without just highlighting. I'm going to go ahead and say this is ray VR. And if I have ray VR and I take another ray, and that could be VW, and I give them the same initial point, they are joined at their initial point. Okay, this is the initial point of both rays, then what do I have? Well, you probably already know it's an angle, right? All right, so let's talk real quick about some angle things we need to know about angles. First of all, you have two rays that make up an angle. So if anybody ever asks you to name the sides of your angle, you are naming rays. Okay? So what does that mean? That means I have to name them like rays. All right? The sides of this angle are ray, I can't say QR because this is not the initial point, and it goes in this direction forever. This is the initial point. So it's ray RQ and ray RS. Those are the two sides of my angle. All right. The point where the two of them meet, we already said that's the initial point for each ray, but in terms of its role as a member of the angle, as a part of the angle, it has its own name. It is the vertex of the angle. So the vertex is that initial point of both rays where they are joined. Okay. Then we have the interior of an angle. And that's basically everything between the two rays. And then we have the exterior, which is everything that's not between the two rays. Now, let me point out to you, don't forget, these little arrows are reminding me that these rays go on forever. So I would not look at a point out here somewhere and say, oh no, that's not between the two rays, because yes, it is. These two rays go forever, and everything in here is interior. Okay, so those are the parts of an angle. Now, a couple reasons that's important. One is because if anybody asks you for the sides, you need to know to name them as rays. Another reason is because the vertex has a very important role in the name of an angle. I'm going to suggest that you start at this point getting in the habit of naming an angle by 3 letters. Okay, 3-letter angle names. For this one could be angle QRS or angle SRQ. Now, a couple of things. First of all, this little angle symbol, that means angle. Another thing that sometimes people do is this. That also means angle. No difference. You could do it either way, really. Okay? But both of these are appropriate names for this angle. Notice that in both cases, the middle letter is the vertex. The middle letter has to be the vertex. The middle letter will be the vertex. So in other words, if I had a picture like this, uh-oh, my cat's coming around again. Okay, if I had a picture like this, and I, as a student, said, okay, I'm going to name this angle RQS. Well, I didn't name the angle you see there. I named this angle. There is an angle RQS. It's not drawn there, but it's there. So I have named a completely different angle. So I can't put the letters in the wrong order. I have to make sure that vertex is second. It has to be the second letter. Now, sometimes it's okay to use just one letter. All right. Sometimes people get confused about when it's okay to use just one letter. And sometimes people are fine with when it's okay to use just one letter. But let's see, what are we going to do here? We're going to do, let's just give our little picture a few things going on. All right. In this particular case, if I say angle F, that is fine. I can name this angle F. If I want to say angle E, that is fine. I can name this angle E. There's nothing else that I can name by one letter. I said that too quickly, didn't I? There's one other angle that I could name by one letter. Think about which other angle that might be. The one other angle that I could name by one letter is C, angle C. And when you name an angle by one letter, you are naming its vertex. The reason it's okay to do that with F and E and C is that look at what happens at all three of those locations. You have two segments that meet there. Think about this as a cabin in the woods. And you are in that cabin and you hear a bear breaking in and you are leaving. So you have to leave fast. There are two ways to exit that cabin and only two ways to exit that cabin. Same thing here. 1, 2. Same thing here. 1, 2. That's when it's okay to name it with one letter. So I can say angle F or angle E or angle C. That's fine. But I cannot say angle D, and I cannot say angle B, and I cannot say angle, well, I could maybe say angle A. I probably wouldn't though. If this is my cabin in the woods, a bear's breaking in the back window, I don't have just two paths. I have 1, 2, 3. If you have more than two paths, that means that there's more than one angle you could mean if you said angle D. There's more than one angle that has that vertex. Here are the angles that have a vertex at D. There's angle EDC or CDE, same angle. There's angle CDB or BDC, CDB. There's also the big angle BDE. I could mean any of those. So if there's more than one angle that could be meant by your angle name, then you cannot give it just a one-letter angle name. You have to give it 3 letters. If that confuses you at all, even a little tiny bit, the best bet is just to always use 3 letters. I can still use 3 letters for this one. I could call it DEF. Or I could call it FED. Okay? So you're basically kind of like you're making a V. When you name it, think of it making a V at the letter. A lot of people have trouble with 3-letter angle names and don't realize they're struggling with it. And they name the wrong angle and get the problem wrong. So like I'm making a V at the vertex. V at the vertex. So if I want to make a V, I would go from D to E to F. So DEF or FED. Now, one thing I want to point out to you about, I pointed out already that you could use either of these symbols for angle. I tend to favor this one, and here's why. If you're not careful, this could look like an L. So just keep that in mind. All right, here's another angle over here. If I want to talk about this angle, let's go ahead and mark it. I want to talk about this angle right here. Think about how to name that angle. All right, I can't name it angle B because there's multiple angles that have a vertex at B. There's this one here, and this one over here, and this one over here. So there's a lot of different angles I could mean if I said B. So I'm going to say angle ABC or CBA. Second letter has to be the vertex, A, B, C, or C, B, A. If you start noticing that you have gotten angle names wrong ever, start literally thinking about, with your finger, tracing the name as you say it. And the second place has to be the vertex. So you go from one end to the vertex to the other end, basically. All right, so sometimes I want to talk about an angle measure. That's when I add a little script M in front of the angle name. That's what that means. That means the measure of angle M. The measure, of angle and then whatever angle. In this case, it's angle EDC. All right, so I would never say angle EDC equals 60 degrees. It's an angle. It's not a number. This is a number. This is an angle. This thing, this angle, this object does not equal that number. Its measure may equal that number. So let's talk about measure of EDC being 60 degrees. Let's assume we have an angle and we want to make an angle that has 60 degrees of angle measure. All right, well, basically I want to start with one side of it. And I'm going to start, one side of my angle is going to be horizontal. And I'm going to let this be the vertex. Okay, so on a protractor, you have a little line that goes through that hole. That little line needs to line up, let me move this out of the glare, with your initial side, okay? The side that is sort of your baseline. And notice that I've also lined up my protractor, not like this, but that line right over there that says 0, 0 has to go through my line as well. So the vertex goes under that hole, and 0 goes through my line. And then remember, I just said this is 0. This is the beginning, so this is 0. 0 is the inside number. That's how you know which set of numbers to use. Okay? Wherever 0 is, that's the set of numbers you're using, because we're starting where this is our first side of the angle. So I'm going to use those numbers and go up to where 60 is on the inside number and make a mark. That's not quite on 60, but it's pretty close. And then I'm going to connect that, and that's about a 60-degree angle. Okay, and that's how we measure angles, is in degrees. So this is the measure of angle. Let's go ahead and call it EDC. And it's about 60 degrees. All right, next, let's go ahead and talk about those different angle measures that we could possibly have and how we describe them, because different angles are described different ways. Before we leave this page, do you know where I'm going with this? Do you know what do we call an angle that is a measure that is less than 90 degrees? Well, it's a little angle, so it's nice and cute, right? It's acute. So acute angles are angles that measure less than 90 degrees. Okay. What about angles that do measure 90 degrees? Okay, if the angle measure, let's say, is equal to 90 degrees. All right. If the angle measure, the measure of the angle, and this is an angle symbol here, the measure of the angle is equal to 90 degrees, we call that a right angle. What about if the measure of the angle is greater than 90 degrees? That's obtuse, but it really doesn't have to be just greater than 90 degrees. It's actually specific, because the next one here, a straight angle measures 180. Okay, so obtuse angles are really angles that are measured between 90 and 180. Okay, but in geometry, we don't talk about any angles that are bigger than 180. So saying bigger than 90 is kind of sufficient. So here's an acute angle. It's less than 90. 90 is a right angle, and we can draw a little box in the corner that indicates that we have a right angle. Okay, so right is the same as 90 degrees. And then here's an obtuse angle. It measures more than 90 degrees. And one thing you can use to measure these sometimes if you don't have a protractor and if you're having a hard time eyeballing it is grab another piece of paper. See if I can find one that's a different color. Grab another piece of paper and use its corner. A corner is a right angle. Now, I didn't use a protractor for that, but I got pretty close. Okay, this is acute. It's smaller than 90. Okay, it doesn't open up more than that. This one's obtuse because you can see there's extra angle once we get past 90. Here's 90. There's still some more angle. So that's bigger than 90. So that can help you. And again, this is called a straight angle. Just like segments, angles that have the same measure, we call them congruent. And just like segments, there's a difference. If I say angle ABC is congruent to angle QRS, that means they have the same measurements. So I would change to equals when I say their measures are equal. So if two items are congruent, in this case, two angles are congruent, then their measures are equals. Or equal, excuse me. All right, let's see. What have we got next to talk about? We need to talk about angle bisectors. We talked about segment bisectors. If I have an angle and then I have any kind of straight object, it can be a ray, it can be a line, it can be a segment, anything that goes through it, you know what? I'm not going to chance it. I'm going to try and get pretty close. Let's see. Goes through the vertex, and it splits the angle into two congruent pieces. In other words, I had my original angle. This is the original angle. Let's give it a name. How about MNP? And I'm going to let that be a Q. So MNP, angle MNP was my original angle, and along comes NQ, and it splits it into two congruent parts. And here's how we do congruent symbols on angles, is we do little arcs, and we make matching arcs. Now, notice that I'm going to offset my matching arc. In other words, I didn't make it to where the two arcs fit right up against each other, because that can make it look like one long arc. And sometimes in geometry, you'll see people use one long arc to mean, okay, this whole angle. Like, in other words, if I did this, well, it's an ugly arc, but that could mean I'm trying to tell you that that whole thing is 100 degrees or something like that. So I made it clear that these are separate little arcs. And you can use sets of one arc, or you can use sets of two arcs. Or three. Sometimes people put little hash marks on them. Basically, you just have matching symbols. And that tells me that these two pieces of the angle, these two smaller angles, are congruent. Okay, so this is an angle bisector, and it has divided angle MNP into two smaller congruent angles, angle MNQ, which is congruent to angle QNP. Be really careful with those angle names. All right, next, we did not use the word. There's one more word that we could use right here. When we have a right angle, another thing we could say about these two rays is that they are perpendicular. These are perpendicular rays. And that reminds me of something else we can say on this page, but we'll come back to it. So if we have perpendicular rays, or it could be perpendicular lines or perpendicular segments or anything kind of straight object that is perpendicular to another straight object, then we have a right angle. We have a 90-degree meeting point. And that's what perpendicular means. Perpendicular means these two things form a right angle. Usually we talk about perpendicular lines. And if we have one right angle, we really have all four of these being right angles. But another thing sometimes we talk about is a perpendicular bisector. Remember that we said that if we have a segment, anything that comes through it and cuts it across through the middle, let's just say that line, that is a bisector of that segment. That is a bisector of segment AB. However, that's not a right angle. Remember that we can use a corner to help us figure that out. That is not a right angle. Okay? Not a right angle. My corner's a little big. So that's not a perpendicular bisector. A perpendicular bisector has to be both things. It has to go right through the midpoint so that it bisects the segment. It also has to be perpendicular. So this is a perpendicular bisector. And we will talk about this a little bit more, but there are some special statements we can make about a perpendicular bisector, like that every single point on that perpendicular bisector is the same distance from A as it is from B. All right, last two things we need to talk about. Segment addition postulate and angle addition postulate. Okay, segment addition postulate is about segments. Angle addition postulate is about angles. Now, let's talk about the word postulate real quick. There are two words we use a lot in geometry that basically just mean math statement. Okay, postulate and theorem. Technically, the difference is a postulate is kind of like those undefined terms where we just sort of say, yeah, okay, this makes sense. We're going to accept that that math statement seems true to us. A theorem can be technically actually proven, and very often you will prove them, and they've all been proven. It's not a theorem until it's been proven, and very often it's one that you could prove, because theorems are based on postulates, just like we use those undefined terms to describe other things and to define other things. So postulate. However, even though I've just told you the difference between a postulate and a theorem, I am not ever going to get too upset with you if you call something a theorem that is a postulate or a postulate that is a theorem, because really they both are fancy terms for math statement. So this is a math fact that's about segment addition. If I have a segment and I have a point that is on that segment, okay? Then this part's length plus this part's length is equal to the length of the whole thing. That makes sense, right? Like if this was 5 centimeters and this was 2 centimeters, then the whole thing would be 5 plus 2 centimeters. So we could say MP, the segment length MP, plus PN, the segment length PN. And I'm deliberately not putting anything on the top because I mean the length of that segment is equal to the length of MN. That's the segment addition postulate. All right, it seems a little bit more obvious with numbers. Sometimes we have to set it up with algebraic expressions. Like let's say that I have same letters, why not? And this is 2x and this is 5x plus 7. And I am told that MN is equal to, I don't know, 26. Now I made it so that it's not going to come out nice and neat and tidy, but that's okay. A lot of times numbers don't. So I can use what I know about part plus part equals the whole. And that's another way I tend to write this as just sort of a reminder. Part plus part equals the whole. That's what we're doing here. So this part plus the other part equals the whole thing, which we were told is 26. So I'm going to get 2x's and 5x's together. That's 7x's plus 7 equals 26. Subtract 7. And I have 7x equals 19. Divide both sides by 7. And I have x is equal to 19 sevenths. And that's my answer. And that is perfectly fine. Fractions are perfectly fine. We don't need to turn it into a decimal. We don't need to get upset that the bigger number's on top. One thing that you will learn going from, and many of you, this may not have been true of your middle school experience, but for some of you in middle school, but especially in elementary school, you were told this was an improper fraction and not to leave it like that. We don't worry about that in high school. That's perfectly fine. We will leave it like that if we want to. And usually we want to. So now that was part plus part equals whole for segments. Let's apply the same thing to angles. And I will apologize because I have already noticed what you have probably already noticed. This video is not a lot shorter than the other one. I kind of expected it to be, but it's not. Okay, so if I have an angle with another ray somewhere in the middle, okay? Another way it's said sometimes is if this point, if we have a ray that goes through a point that is in the interior of the original angle, in other words, this point is between the sides of this angle, then this part plus this part equals the whole thing. So let's kind of color code that. This part plus this part is going to give me the entire thing. So let's find some letters for that. The measure of angle ABC, we're talking about measurements because we're adding. When we're talking about addition, that's something we do with numbers. So the measure of ABC plus the measure of CBD is equal to the measure of ABD. Part plus part equals whole, or the two smaller angles add up to the bigger angle. All right, so we can use that to find missing parts. We can use that to create algebraic equations we can solve. So for instance, let's say I have and I'm using totally new letters, so we're going to draw a line there. Let's say I'm told that measure of angle RTP is equal to, what do I want to make it equal to? 7x plus 8 degrees. Well, this part, the smaller angle here, plus this part over here, has to equal that whole big part we're told about. So part plus part equals whole becomes my equation. That's what this is saying. One smaller angle plus the other smaller angle equals the whole thing. And then I can solve that equation and find out what the measure or what the value of x is and find out the measure of these two angles. But the main thing that the angle addition postulate tells me is how to set it up. Okay, it's telling me how to go ahead and recognize that these two parts add up to the whole thing and that I can use that to create an equation. Because anytime you have something you don't know, an unknown, a variable, you have to solve. And the thing you have to solve is an equation. So you can't do it until you have an equation. So this helps us write that equation. And thank you for your patience because we got through everything we needed to talk about with respect to angles. And that is that. And I'm not going to make it last any longer. Thanks so much for being with me. And I'll see you next time. Bye-bye.